Okay, hi everybody. We're doing section 10.7 today, and we're finding and comparing experimental and theoretical probabilities. We need to know what those words are, and then we're going to predict the actions of a larger group. So first let's talk about what theoretical and experimental probability are. Theoretical probability is what should occur when conducting a probability experiment. For example, you're flipping a coin. The amount of times that you should get heads would be 1 out of 2. It should be about 50% chance that you're going to get a heads. So that's theoretical probability, what should happen. Experimental probability is what actually happens when an experiment is repeated several times. So you're flipping the coin and you do it however many times and you record what happens. It might not necessarily be 50% of the time that you get heads. It'll be close the more times you do it, but it won't necessarily be 50% exactly. So let's look at some of both of these kinds of problems. We're going to do 4 problems. You're going to write down all of the problems. Again, you're going to write down all the problems and the work, and we'll do more in class. So, number 1. The table shows the results of an experiment in which a number cube was rolled. So here's, you can get either a 1, a 2, a 3, a 4, a 5, or 6. These are the possible outcomes. When they rolled the 1, they got it 4 times. A 2 was 6 times, and so on. So this is how many times they got each number. It says, find the experimental probability of rolling a 5 for this experiment. So experimental probability, the reason why they say that is because we're not giving the theoretical probability, what should happen, of rolling a 5 from what is going on here. So that's our first thing that they would like us to do. So the probability of rolling a 5, they have it 4 times, they got a 5 4 times, out of, does it say how many? No. So this is 10, another 10, 20, 29 times. Okay, let's also make that into a percent. So 4 divided by 29. 4 divided by 29. You get 14%. Then it says, then compare the experimental probability with the theoretical probability. Theoretical, so this is our experimental probability. Probability of actually rolling a 5, so this will be our theoretical. You should get a 1, you should get it 1 out of 6 times. 1 out of 6 is 16.6 repeating percent. Okay, let me just check that to make sure my calculator over there. Yeah, this is about 14%. It's 13.8% here. Now they want us to compare it. So this probability, our experimental, is a little bit less than our theoretical, but it's kind of close. So if we had done this a bunch more times, it would reach closer, hopefully, to 16.6 repeating. So right now, if we compare them, the experimental probability is a little less than the theoretical. Okay, so we just wrote a sentence about what's going on. Experimental, theoretical, comparing. Let's do another one. A coin was tossed 40 times and heads came up 18 times out of the 40. Find the experimental probability of getting tails for this experiment. Okay, so if heads came up 18 times, to get tails out of the 40, because they would have to add to 40 times, you do 40 minus 18, you get 22 for getting tails. It says, find the experimental probability of getting tails for this experiment. So our probability of getting tails is 22 out of 40. 22 divided by 40 gives me 55%. Our theoretical, because then it says compare the experimental probability with the theoretical, probability of getting tails should be 1 out of 2, which is 50%. So the sentence we could write here is that our experimental, first one, is a little bit higher than our theoretical, but fairly close. Okay, so now we're going to take our experimental and we're going to make predictions. Miss Yoon surveyed her class to see which sports they preferred watching. 44% preferred football, 28% preferred basketball, 20% soccer, and 8% tennis. Out of 560 students in the entire school, how many would you expect to say they preferred watching basketball? So what you're going to do is find the basketball, 28%. This is what she surveyed out of her students. So you would expect it to be similar across the entire school. It doesn't definitely make it, but this is a prediction. So you take what you found in your experiment, and you're going to take that percent times the total. So we have 28%, 28 out of 100, or you can write 0.28, times our 560. 0.28, or 28 out of 100 times 560. We would expect, well, when you multiply this, you get this, and you can't write part of a person. So we would expect 157 to say that they prefer, 157 students to say that they prefer basketball. Okay? We'll try one more, and then we're done for today. The chart to the right shows the number of people wearing different types of shoes in Mr. Thompson's English class. Suppose there are 300 students in the cafeteria. Predict how many would be wearing low-top sneakers. Explain your reasoning. So first, low top would be 12 out of, let's see, this is 10, this is 20, so out of 30. 12 kids out of 30. That's our probability for low-top sneakers, our experimental probability. And we want to do that times 300. So we should get 120 there, but let me just double check that, make sure that my math is on target. For those of you who weren't sure what I did, divide 300 by 30, you get a 1, you get a 10. 12 times 10, 120 students would be expected to wear low-top sneakers. And to explain, I would write something to the effect that since 12 out of 30 of his students expected that I'd use the experimental probability times the number of students to give me an estimate for the amount of students who prefer low-top sneakers. That's it for today. Have a good one.